Welcome to this video. I'm Evan, a developer on the journey to becoming an indie developer. In this episode, I'll walk you through today's development tasks and checklist. If you're interested in indie game development, let's get started. Now, let's create our first script. Right-click in a blank area of the project window to create a new script. Name it Test or whatever you like, press Enter. And that's it, your first script is created. Pretty simple, right? Double-click to open the script. You can see that Unity has already generated some default content for us. Let me walk you through it from top to bottom. First, we have using. For example, in real life, if you need to do specialized work, you first have to go to the tool room or warehouse and grab the right toolbox, otherwise the job is much harder to do. Using is like that grabbing the toolbox action. What follows is the name of the toolbox, such as Unity Engine. This allows us to easily access and use Unity's built-in tools. Next, let's look at this section. The keyword public at the beginning, I'll explain that in detail in a later video. Now, class, you can think of it as a design blueprint. What comes right after is the name of that blueprint. Generally, the blueprint name should match the script file name. If they don't match, Unity may have trouble recognizing and linking the script to the object. We'll see that later. On this blueprint, you can design what you need. For example, if you're creating a character, you could define their name, health, speed, and even actions like attacking or healing. After that, you'll notice mono behavior. Following the class name. Think of this as Unity's built-in universal template for blueprints. Here's an example. We've already designed a weapon blueprint .character A. Wants this weapon to fire lasers, but character B wants it to behave like a boomerang. Starting from scratch each time would be too much work. Instead, we can take a copy of this universal template and extend it with our own custom functions. This saves us from repeating the same design steps. We just focus on what's different. All right, that should give you a basic idea of what's here. We'll dive deeper into inheritance and other concepts in upcoming videos. Next, let's look at the pair of curly braces in the script. These matching brackets act like a container, wrapping everything that belongs to the test class. Now let's see what's inside this container. A structure like this is called a method in scripting. You can think of a method as a collection of related actions. Here's an example. I'm sitting on the couch, feeling thirsty, so I trigger the drink water method. This method includes a series of steps: finding the cup, checking if there's water in it, picking it up and drinking, all bundled together as one action called drink water. In a game context, when a weapon attacks, it calls the attack method. Inside that method, we might check if an enemy was hit, calculate damage, play a hit sound effect, and more, all executed together within the same method. Next, we have the start method. When the game object carrying this script is created, Unity automatically calls start once and only once. It's typically used for initialization, like setting starting health or linking components. Then there's the update method. If you're familiar with frame rates in games, you know the screen updates frame by frame. The update method is executed automatically once every frame. This is where you'll usually put ongoing logic, like continuous movement or checking for player input. We'll go deeper into update and the script lifecycle in the next video. For now, just know this. Update is the heartbeat of your game, running constantly, frame after frame. Now let's talk about another key concept in scripting: variables. You can think of a variable as a container for storing data. In a game, information like the player's health, movement speed, or gold count is stored and managed using variables. You can find a real-world parallel in a sticky note system. You might put notes in visible places at home to remind yourself of things you might forget, like on the fridge. Milk? 2 bottles left. Need to buy 12 eggs? Or friend's birthday is March 15th. Now let's try defining a variable in the script. A variable mainly consists of 3 parts: access modifier, data type, and variable name. There are 2 common access modifiers: public and private. Public is like posting a sticky note in the living room. Any guest can see it. Private is more like keeping a note in your personal diary, only you can see it. Next is the data type. Here I'll introduce 3 of the most basic ones. Int stores whole numbers, like 0, 1, or 100. Float stores numbers with decimals, like 3.14f. Note the f at the end. String stores text, like hello, or player name. You can think of data types as different shaped containers, each suited for holding specific kinds of things. Finally, the variable name. This is the label on the container. Just like you'd look for the note that says milk to check how much is left, you give variables clear names like health, speed, or player name so you can use them correctly in your code. Okay, let's try writing a variable. After the type and name, you can also use an equal sign to give it an initial value. If you don't set one, the system will assign a default value automatically, like 0 for numbers. Also, if you don't specify an access modifier, the system treats it as private by default. We'll see why that matters when we start calling scripts later. Once a variable is defined, you can change its value anytime later in the code using the equals sign. We won't see the results just yet, but don't worry. Later in this video, we'll see exactly how it works in the game. All right, do you remember the relationship between game objects and components we talked about earlier? In fact, the scripts we write are also a type of component, as long as they inherit from mono behavior. Now, back in Unity, let's create a game object. To make our script actually work, we need to attach it to this object. There are 2 common ways to do that. First, you can just drag the script from the project window and drop it onto the object in the hierarchy. Second, you can click Add Component in the Inspector panel of the object, then search for or select your script. Once it's attached, the script becomes a component on the object, and the logic we wrote will start running on it. Great! The script is now successfully attached to the object. Next, let's try printing some information. Back in the script, we can type a statement like this to output messages. Here, I'll define a few more variables to check what happens with uninitialized values and values that have been modified. All right, back in Unity, and let's hit play. We can see the output in the console window. One additional tip. If you need to assign a value of a different data type to a variable, for example, if I want to assign a number with a decimal point to an integer variable, we need to perform type casting. You can do it like this by adding int in front. The same applies when converting between other types. Just add the corresponding type marker in front. All right, let's print again and see the result. As you can see, the outputs all match what we expected. All right, everyone, that's it for today's video. If you enjoyed it, don't forget to like and subscribe. If you have any suggestions or thoughts, feel free to leave a comment. Let's discuss together. Here is the checklist for the next video. There's more exciting content coming, so stay tuned. I'm Evan, and I'll see you in the next video.